product of sum and difference of two terms. So what is this and how to apply this formula in the problems also I'll explain. So two terms. So let me take A is a term and B is another term. There are two terms. Product of sum and difference. Sum means addition, so plus, and same difference. So other two terms, A minus B. One is positive, one is addition, one is subtraction. So sum and difference of the product, that is A plus B into A minus B is dash. So such type of problems also will come in examination point of view. So A plus B into A minus B is what? So first of all we'll solve using this distributive law, then we'll find out the identity of this using product of sum and difference of two terms. Okay, when you apply, first is A, multiply full second expression, that is A minus B, plus second term in first expression and multiply with A minus B. So already we discussed previous. Now if you simplify, A into A is A square minus A into B is AB. So that is like this. First term multiply the both ones, that is A into A square, again A into B is AB, so minus AB. Similarly B into A, again B into minus B we need to write. So that is plus B into A is BA minus B into B is a B square. Now A square minus AB plus BA or AB, both are same, A into B or B into A, minus B square. So minus AB plus AB can cancel here. After cancellation we got A square minus last term is B square. Okay, this is the formula now. So we can conclude this as identity A plus B into A minus B. So is equals to A square minus B square. For any two terms, the product of sum and difference will come the square of the first term minus square of the second term. So in that way you can remember this. So these are formula how to apply in the given problems. So let me explain now. So apply the same thing. Now for example, find the product. Okay, find the product of, so I'm taking two questions like 7x plus 3y into 7x minus 3y is one problem, and one numerical sum. Okay, first let me solve this. So when you observe here, product sum and difference. So once you take positive, once you take negative, that is 7x plus 3y into again 7x minus 3y. So need not to apply again distributive law because the two terms with plus and minus separate sign. So if you apply this formula, that is A plus B into A minus B is equals to what we got, A square minus B square. Okay, so this formula you need to apply. So you remember this. That means first term square minus second term square. So here 7x is first, 3y is second. Same 7x and 3y. So that we can write 7x overall square, because not only 7x square, 7x whole square minus 3y is the second term. So apply the bracket because there are two numbers, number and numerical value and literal variable also is there. So apply the whole square. Then try to solve this. That is 7x whole square means 7x into 7x. So 7 square is 49, x square is x square only, minus 3y overall square. So 3 square is 9 because 3 3 is a 9, and y square. That's it. So 4x square minus 9y square. So need not to expand with the distributive law and again to solve. So we can apply directly like this. And so this is only unit formula applying in everything. Let me explain with one fractional problem also similar. Find the product of 3 by 5p plus 1 by 3 into same terms, that is 3 by 5p minus 1 by 3. Value of this is dash. So I'm not writing identity, already got the identity now. So directly what you can write, 3 by 5p first term whole square and minus second term is 1 by 3 the term whole square. That's it. Now each and every letter in this whole square you need to do squaring. That is 3 square is 9 by 5 square is 25 and p square is b square. Minus here 1 square is 1, 3 square is 9. So for everything you need to apply. This is only the solution for that. And let's see one sum of decimals. So find the product of, there is 1.2 m plus 0.2 n. 1.2 m into 0.2 n, again 1.2 m minus 0.2 n. Fine. So try to solve this. So what you can write when you apply the identity. So identity or the formula is a plus b into a minus b. Whereas a minus b into a plus b also same. So that is a square minus b square. So according to this identity, so we can write 1.2 m whole square minus 0.2 n whole square. So 1.2 into 1.2 directly can multiply. So 1.2 into 1.2 because whole square is there. That is 2 to the 4, 2, 1. So after 144, then we need to keep the point at here. Because after point 1, 2 decimals you need to leave. That is 1.44 m square minus 0.2 whole square. So 0.2 whole square is 0.04 because 2 to the 4, but we need 2 decimals after point. So n square. Okay. Already you are well known about this decimals conversion to the squaring. Okay. So this way we can solve. Now whenever they are asking about three expressions combined, also let me explain on some. So if you observe here, x plus 2, so find the continued product. So when you give more than 2 expressions, you will see continued product of this. Find the continued product of, now question is x plus 2 into x minus 2 into x square plus 4. So if you observe the first two expressions, x plus 2 into x minus 2, so that is identity, that is x square minus 2 square, right? And third expression as to the right, x square plus 4. Now simplify this, x square minus 2 square is 4, in the bracket again last one is x square plus 4. So if you observe second time also, you should apply the same formula now. Same formula, that is a minus b into a plus b, because two terms are same. So according to identity, that is a square minus b square. Okay, this identity will apply. So when you apply this same identity, we can write, okay, see here, there is x square minus 4, x square plus 4. So first term is x square, for that square, whole square, minus second term is 4 square. Okay, x square whole square is x to the power 4 minus 4 square is 16. That's it. So this is the way we can solve. So any problem is given, we need to verify, first understand that the product of sum and difference of two terms formula is applicable or not. So once it's able to do, then directly we can apply. And using the same identity, we need to solve some numbers also. So in examination point of view, they ask questions like this. For example, use the identity. Okay, this also listen now. Use the identity. So which identity? That is a plus b into a minus b is equals to a square minus b square. Using the same identity only, just to evaluate or solve. So when you take evaluation, so evaluate (34 into 26). So 34 into 26 value you need to find out. Actually 34 into 26 you can do normally, like normal multiplication, but using identity. That means first to 34 I should write product sum of two numbers, same difference of numbers should come 26. Now to make, if you observe 34, 30 plus 4, and check 30 minus 4 is 26 or not. Yes, 30 minus 4 also 26. It should be matched exactly. Okay, first number should be equal to 30 plus 4, second number should be equal to 30 minus 4. Again, letters also must be same, means first term and second term should be same as it is in the second expression also. Then if you apply identity, this is already given, a square minus b square, that is 30 square minus 4 square. So 30 square is 900 minus 4 square is 16. So 900 minus 16, just subtract 884. Okay, like this. And when they're asking about the same identity in the fractions also, so let me give one more question. And they're given fractions. So for example, multiply 6 2 by 3 into 5 1 by 3 is dash. So how to split this? 6 plus something and 6 minus something, because 6 is a big number. So check it now. 6 plus 2 by 3 is 6 2 by 3, mixed fraction. And 6 minus 2 by 3 is 5 1 by 3 only. Exactly will come. So similar, which is able to solve type of questions only they'll give. So you can apply the identity, that is a square minus b square. So that is 6 square minus 2 by 3 whole square. Now if you simplify, 6 square is 36 and minus 2 by 3 whole square is 4 by 9. Okay, solve this. If you simplify, 9 is LCM, 36 into 9 minus 4. So 36 is 9, multiply and subtract 4. That is 324 minus 4. So 320, right? By 9. If you convert it into mixed fraction, that is 35 5 by 9. So converting into mixed fraction only, because the question is given mixed fractions. So this way we can simplify it easily, and which is given. And which is not able to do also, we can make it by converting into mixed fraction into improper fractions. So let's see one question here. By converting, that means question is asked 6 4 by 5 into 9 1 by 5. Now directly can't solve this if you convert into. So now first of all convert into the mixed fraction into improper. That is 5 6 30. 34 by 5 into 5 9s are 45, 46 by 5. Now observe 34 and 46. Okay, that is 1 by 25. Denominators I took separately. Numerators are 34 into 46. Now 34 into 46, 1 by 25 as it is. Here apply 34 into 46. That is 40 minus 6, 40 plus 6. Okay, only for this top values. 34 is 40 minus 6. That 46 is 40 plus 6. So if you apply 1 by 25, so 40 square minus 6 square in bracket. So that is writing here. So 1 by 25 in the bracket, 40 square 1600, 6 square is 36. So subtract 1 by 25, 1600 minus 36, this is 1564, right? 1564. So finally that is 1564 by 25. If you convert into mixed fraction, 62 14 by 25. So do division, you can convert into mixed fraction. This way, in case if it's not possible to solve, just to convert into improper fraction, then you can get clearly about idea. So what identity you need to use. Okay, and these are the a plus b into a minus b. So only a square minus b square identity only applied, this identity. Okay, not only this, some more identities are there. So that is the squares of binomials. So how to apply the squares of binomials? First I'll explain you formulas of squares of binomials, that is expansions. Then I'll explain you how to solve the problems also in the squares of binomials now.